Hi everyone, now we are going to discuss the percentage or biased differential relay. You know the differential relay means what? Entering current and outgoing current to measure the phasor difference. Okay, in that percentage or biased differential relay. See, see the previous they have discussed some disadvantages of the mall operation of the simple differential relay due to the CT errors, because mall operation means a faulty. Because of faulty reasons, relay start to operate it and turn off the circuit. Okay, so that is what mall operation. So in that mall operation also differential relay start operating. To overcome those disadvantages, we are going to discuss the percentage or bias type of the differential relay. Okay, that is mainly during the heavy external faults. See here the percentage biased over the percentage differential relay. This is the what percentage differential relay circuit diagram. See here the percentage differential relay provides a high sensitivity to the light internal faults with a high security for external faults. So and makes the differential protection scheme more stable than compared to the previous one. Okay. See, this has mainly two coils. One operating coil and one more is restraining coil. Okay, see here you know that when relay start operating coil must greater than the restraining coil. Whatever detects that operating should be greater than the restraining torque. Okay, the about the torque we have discussed electromagnetic type of relay. Operating torque should be greater than the restraining torque, then the relay start operated. Here also same concept. The operating coil which produces the operating torque for the relay operation. Okay, when the operating torque exceeds the restraining torque, relay start operates it. Okay, the operating coil is connected at the midpoint of the restraining coil, as here showing. The restraining coil number of turns are NR, but it is half of connected here. The middle of this is connected operating coil, so half number of turns here and another half number of turns here. Okay, the number of turns here is NR by 2 and here is NR by 2. Okay, so this is tapped at the center. It forms two sections with the equal number of the turns. Okay, that is NR by 2. See, I1 of PS current flowing through this coil and I2 of S from the CT current is flowing through this here. So total current is flowing here is I1 plus I1S and here is I2S, so that it can manage the one section here current through by NR by 2 and here is by NR by 2 and I2S is flowing, so that complete restraining coil of NR turns receives the current through the this is the current went through the fault current. That is fault current, nothing but external. Okay, external fault. Okay, so total current here is I1S by 2 here and here I2S by 2. Total is I1S plus I2S divided by 2. The operating coil having NO number of turns. O means operating coil. Number of turns here is NO, that is N0. So is connected in the spill path. Okay, spill path, that is difference path, so that it receives the differential current from this CT and from this CT. This CT secondary current is I1S and here is current is I2S. Whatever difference is there between I1S and I2S, that difference current is flowing through the operating coil. Okay, so the operating condition of the percentage differential relay can be derived by using the formulas that is they have given here. The relay operates if operating coil produced by the operating coil is obviously more than the restraining coil produced by the restraining coil. As the torque is proportional to the ampere turns, you know that torque is proportional to the ampere turns, that is 80. The relay will operate when the ampere turns of the operating coil will be greater than the ampere turns of the restraining coil. So that here they have given ampere turns. Left side is NR by 2 and current flowing is I1S. Okay, turns and current. So right hand side is NR by 2 and secondary current is I2S. Total current through the restraining coil is I1 plus I2. The number of turns is NR by 2. Here we can change this equation like this. Okay, so here IR is equal to I1S plus I2S divided by total current flowing through the restraining coil, that is IR. And similarly through the operating coil, the ampere turns is number of turns for the operating coil is N naught. Difference between the two currents is I1 and I1s minus I2s. Okay, so when the your relay start operating, ampere turns of the operating coil is greater than the restraining coil. Therefore, ampere turns of operating coil is greater than the restraining coil. So put the equation both sides. So we have taken this is as the I1s minus I2s is difference between the current, that is ID should be greater than NR by N0 means constant K. You know that N2 by N1 is ratio K. Okay, that is secondary. By primary we have taken right in the transformer like that, NR by N0 means K, and this is your current through the restraining coil, that is total current is IR. IR is equal to this much current is flowing through the restraining coil. Okay, that is K is what? Slope or bias. Okay, at this condition relay start operating. ID is equal to K into IR times. Okay, so next is what? This is what the operating characteristics of the percentage bias relay. Okay, see here, and one more equation they are given here. ID is equal to K into IR is our equation plus Ks is right. Ks is what here? Having a slope K and an intercept Ks on the y-axis. Intercept Ks, okay, that is intercept value Ks is on the y-axis. All points above the straight line represent the condition. See here the slope. Okay, see this is the Ks value. Y-axis the intersection. Okay, these are the white point, intersected point that will give the Ks at the y-axis values. The operating characteristics of the percentage relay is a straight line having a slope of K and an intercept Ks on the y-axis. All points above the straight line having a slope of K represent the what? The condition where the operating torque is greater than the operating character is greater than the restraining torque. And that is the reason. Blocking reason is what? Restraining. Trip is what? Operating reason. Okay. The operating characteristics of the relay is like this. Okay. This is what characteristics of the operating coil. The percentage differential relay does not have a fixed pickup value. The relay automatically or it adapts its pickup value to the restraining through the current. Okay, as restraining current goes on increasing, the restraining torque also increases, and the relay is prevented from the mal-operation, so that the restraining winding biases the relay towards the restraint. It is also known as biasing winding. Okay, this is about the percentage biased winding. Sometimes they may ask stability limit and stability ratio. This is the theory part that we can read and we will get it. The very easy stability ratio is IF dash maximum divided by IF dash minimum. Faulty current maximum divided by minimum current. Okay, this is what characteristics and types of percentage differential relay. This is the word. This is what types. See here, first one is fixed percentage. This is fixed percentage type. Second is variable percentage type. Okay, so the two types of percentage differential relay. Then settings of percentage differential relay. Okay, sometimes they may ask settings of percentage differential relay. Okay, basic settings or sensitivity setting, that is percentage set. Basic setting is what? Minimum current in the operating coil to cause the operation. Minimum current divided by rated current of the operating coil. Usually the bias, when the bias is 0, number of turns, that is restraining turns, are 0. Okay, the bias setting. So see here, bias setting is equal to K is equal to slope, that is NR by N0 into 100, where NR is what? Number of turns of the operating coil, the divided by N0. It is inversely proportional to the what? Current. Okay, therefore current through the operating coil is difference between the two currents, and NR is what? Number of turns for the restraining coil. The current flowing through the restraining coil is I1 plus I2s divided by 2, because half of turn is divided at the both sides. Okay, so we'll see the problems. Okay, you go through these problems, otherwise I will discuss in the next video.